second order homogeneous linear differential equations. This will be the easiest form of them. We're just going to do constant coefficients. So it'll look like that. AY double prime plus BY prime plus CY equals 0. The first thing we're going to do to solve these types of equations is we're going to do what's called what I call an R transformation. So we're going to leave all the coefficients there, and you're just going to take the order of these y's and turn that into an exponent of r. So y double prime becomes r squared, y prime becomes r, y becomes r to the 0, which is just 1. And next up, you're just going to solve that quadratic equation. Now when you solve it, there's going to be 3 different cases. So in case 1 here, we have 2 roots. So the graph will look something like that. You'll get the example here, r minus 2 times r plus 3. You'll have r1 equals 2, r2 equals negative 3. So the solution to these looks like this. You can just jump right to it. It's y equals c1 e to the r1x plus c2 e to the r2x. It doesn't matter which is r1 and r2, it's the same thing. That's the easiest one. Case 2 is when you're going to have one root. So it'll just kind of come tangent to the x-axis there, and it'll look like something like this. It'll be something squared. R minus 2 squared might be r squared, anything like that. So we have one root. In this case it's r equals 2, and here your solution looks like this. Y equals c1 r to the x plus c2 x e to the rx. That x is the difference. So those are the 2 easy ones. Case 3, a little more complicated. You're going to use the quadratic formula because you have no roots. It does not touch the x-axis. You're going to use the quadratic formula here, and the square root part will be negative. So you're going to have to use complex numbers. When you work all that out, simplify it out, you get it in the form of this. Alpha plus minus beta I. Once you've got that, you get that big ugly thing. That's your solution to this type of equation. It's y equals c1 e to the alpha x cos beta x plus c2 e to the alpha x sine beta x. And those alpha betas just right from here. So this alpha will be, from your quadratic formula, be negative b over 2a. And beta will be the square root b squared minus 4ac over 2a, and of course you'll have to pull the I out of that because this will be negative. So let's write those all in one place. If you have 2 roots, it looks like this. 1 root, no roots. I highly suggest you write it in your notes just like this, so you have it all in one place, and it's easy to reference later on. Okay, so let's do some examples here. First example here, we have y double prime plus 5y prime plus 6y equals 0. So we're going to do our R transformation here. We get r squared plus 5r plus 6. And factor that into r plus 2 times r plus 3. So here we have 2 roots. R equals negative 2 and r equals negative 3. So we can just plug that into our formula for case 1. And we get y equals c1 e to the negative 2x plus c2 e to the negative 3x. That's all there is to that one. So example number 2. We have y double prime plus 2y prime plus y. Do our R transformation, we get r squared plus 2r plus 1. Factor that, it's r plus 1 squared. So we only have one root here. That means we're in case 2. So we plug r into the formula for case 2. And we get y equals c1 e to the negative x plus c2 x e to the negative x. And that's it for that one. Example number 3. Here we have y double prime plus 2y prime plus 2y equals 0. R transformation, we get r squared plus 2r plus 2. And we use the quadratic formula here because I don't know how to factor that. So we have r equals negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 2, all over 2. And reduce that a little bit more, you got r equals -1 plus minus square root of -4 over 2. Now, because we have square root of negative number, we're into complex numbers here. So we take out an I. I is, of course, the square root of -1. So we have -1 plus minus root 4 over 2i, which is -1 plus minus I. So we have no real roots, so we're in case 3, and we've already reduced it here into the formula that we need. R equals alpha plus beta I. Alpha is -1, beta is 1. So we just put it in our formula. Y equals C1 e to the negative x. There's your alpha, -1. Cos beta x, beta is just 1, so cos x, plus C2 e to the negative x sine x.